Today we will be solving quadratics using the quadratic formula. This is TEKS Algebra 2 4F. So the first rule of solving with the quadratic formula is ensuring that all the terms are on one side. So in this case we can see that all the terms are in one side. Next, I would start off by labeling my terms A, B, and C. A is always going to be the number that's in front of your x squared. B is always going to be the number that's in front of x. And C is always your constant. It's your number that doesn't have a variable. So our A value is 1. Our B value is -4. And our C value is -8. So using the quadratic formula, I'm going to find up to 2 solutions. I have the positive solution and I have a negative solution. So I can do plus the square root and I can do minus the square root. So every variable in this equation is going to be filled in with a number. Again, we can have up to 2 solutions. X equals, on the top we have -b. We have a plus or a minus, the square root, b squared minus 4 times a times c, and all of that fraction is over 2a. Okay, so now we're going to look at these double negatives. We're going to square this number and we're going to multiply all 3 of these numbers and multiply this number. So let's start on the first one. X is equal to a -4 becomes a +4 plus and minus the square root. -4 squared is a +16. This number will always be a positive number. And then I have -4 times 1 times -8, and this becomes a +32, all divided by 2. I'm going to work on my discriminant first, which is what's underneath the radical. So x equals 4 plus or minus the square root of 16 plus 32 is 48 divided by 2. So for 48, I want to figure out how to simplify the square root of 48. So you can do the factor tree, or you can look for perfect squares that go into it. So 48, you can do the factor tree. I'm going to go ahead and do the perfect squares that go into 48. A perfect square being 16 times 3. 16 times 3 gives me 48, and I can take the square root of 16, which is 4 square roots of 3, because the 3 stays underneath your radical. So that I have x equals 4 plus and minus 4 square roots of 3 over 2. Let's see if I can simplify by reducing each term by 2. 4 divided by 2 and 4 divided by 2 becomes x equals 2 plus or minus 2 square roots of 3. So this problem does have 2 solutions, and you may have to write this as a positive solution, or you may write this as a negative solution, or we can write it as a plus or a minus. Okay, the next problem will increase in speed just a little bit. We have A, we have B, and we have C. Everything is already on one side, so I'm going to label my A as 4, my B is a +3, and my C is a -2. Using the quadratic formula, I have x equals -b. Wherever I plug in a number, I'm going to write parentheses, plus and minus the square root of b squared, minus 4 times a times c, all divided by 2 times a. So let's go ahead and get rid of the parentheses. We have a -3 plus and minus the square root. Now our discriminant, 3 squared is 9, and this is where the mistakes happen right here. -4 times 4 times -2. So double negatives becomes a positive, and it's a 32. all divided by 8. So let's look at the number underneath the square root, which is our radicand, but it's our discriminant to let us know how many possible solutions. 9 plus 32 is 41. Can I simplify 41? Are there any numbers that go into 41 that I can take the square root of? No, because 41 is a prime number. I cannot even divide these, so I'm actually done with this problem. So if you cannot simplify your radical and you cannot divide by this on either term, then this is your final answer. This is your most reduced answer. Okay, our last question. Again, we make sure that the terms are in order. In this case, they are. So we're going to label our A as 2, our B as -7, and our C as -4. So again, we are following the quadratic formula and we're putting everything in its place. So we start off with x equals -b. So notice the parentheses, plus and minus the square root. -7 in parentheses squared minus 4 times 2 times -4. All divided by 2 times 2. Our next step is going to be to get rid of the parentheses. So we have a -7. That becomes a +7 plus and minus the square root. Okay. We have -7 squared. Remember, this is in parentheses, so it always turns into a positive number, 49. Then we have -4 times 2 times -4. Look, we have 2 negatives, so it's going to turn positive. So -4 times 2 times -4 is a positive 32, all divided by 4. Okay. What is 49 plus 32? We're going to have x equals 7 plus or minus the square root of 81 divided by 4. 81 is a perfect square. I can take the square root of it. If you can take the square root of it, we are going to break it up into two equations. Essentially, the reason why, so I don't typically show this step, but I'm going to for right now. The square root of 81 is 9 all over 4. So notice I have 7 plus or minus 9 over 4. So I'm going to break it up actually into 7 plus 9 over 4 and 7 minus 9 over 4. And x equals both of these terms. Okay? On my left side, 7 plus 9 over 4 equals 16 over 4. And 16 over 4 reduces to a 4. 7 minus 9, that's a -2 over 4. We want it reduced as much as possible. X equals -1 over 2. So again, if you can take the square root of it, we're going to break it up into actually having to do both solutions, since we can't write this as a plus or minus for my solutions. But I did the positive solution and I did a negative solution, meaning the negative version of the square root and the positive version of the square root. Hopefully this video helped you understand how to solve quadratics using the quadratic formula.